Resistor. Resistor is a passive, two-terminal electronic component that limits the flow of electrons inside a circuit. The value of the resistor is called its resistance. Ohm is the unit of resistance. For higher values, we use kilo ohm and mega ohm. Higher the value of resistance, lower the current can pass through it. This is the symbol for the fixed value resistor, and it is the symbol for the variable value resistor. Resistor is used to limit the flow of current in a circuit. For example, if we want to glow an LED using a 5 volts battery, then we must know the turn-on voltage and current consumption of that LED. If we not use the right value resistor, then battery can damage the LED by giving it high voltage and current. Suppose this LED needs 2 volt to turn on and 15 milliamperes current to operate. So, to operate this LED using a 5 volt battery, we need a resistor which can drop 3 volts across itself and allow to pass only 15 milliamperes of current through it. To calculate the value of the resistor, we will use the Ohm's law. V equals IR. So, in this formula, we will put the value of voltage V, 3 volt, and the value of current I, 15 milliamperes, then the value of R will come out to be 220 ohms. Now we will calculate the desired power rating of the resistor by using the formula, P equals VI. It is 45 milliwatts. So, we must use the resistor, which can bear at least 45 milliwatts of power dissipation. When we connect several resistors in series, then the final value is the sum of all the resistors. If we connect 1, 2 and 6 kilo ohms resistor in series, then the final value will be 9 kilo ohms. When we connect them to a power supply, then same current will pass from each resistor, but the voltage drop across each resistor will be different. If we connect them in parallel, then the final value of resistor can be derived from this formula. In parallel connection, voltage drop across each resistor will be same, but the current passing from each resistor will be different. This configuration of resistor is called voltage divider. This configuration is used to drop the voltage. By using this configuration, we can set various values of voltage at its output. For example, if we assume that the value of resistor R1 is 1 kilo ohm, the value of resistor R2 is 9 kilo ohm and the input voltage is 5 volts, then the value of output voltage can be calculated using this formula. It will be 4.5 volt. By using the same formula, the values of the resistors R1 and R2 can be derived if the output and input voltage are known. If we use a variable resistor in place of R2, then the output voltage will change with the change in value of resistor R2. There are many types of sensors whose internal resistor value depends upon the environmental conditions, such as the value of a thermistor varies with temperature. If we use a thermistor in place of R2, then the value of the output voltage will change along with the value of the temperature. This principle is used in a digital thermometer to measure the value of temperature. The classification of resistors is done on many grounds. On the basis of mounting, resistors are of two types: SMD, surface-mounted resistors, and PTH, plated through-hole resistors. On the basis of value, fixed value and variable value resistor. On the basis of orientation, radial and axial resistor. On the basis of construction, metal film, carbon film and wire wound resistor. These sensors are also a form of resistor. They change their resistance when the temperature is changed, or when the force is applied, or when it is folded. The multimeter can be used to measure the value of the resistor. Value of the resistor can also be derived from its color code. Resistor has a specific number for each color. Like number 0 is of black color, number 1 is of brown color. Now, let's find the value of the first resistor, given in the chart. The first color in this resistor is red, so the first number is 2. The second color is purple, its number is 7. Third color is of multiplier, the third color is yellow and its number is 4, and will be right as 10,000, 4 zeros after 1. So the value of the resistor is 27, multiplied by 10,000, or 270 kilo ohms. Last color is of tolerance. Resistors can have up to 6 color bands. First 3 colors indicates resistor value, and the rest colors indicates the characteristics of the resistor, like tolerance and temperature coefficient. In SMD resistors, the values are printed in the form of numbers, such as 472 means 47 multiplied by 100, and it is 4.7 kilo ohms. This was some basic information about resistor. I hope you enjoyed the video. Thank you so much.